Welcome to Orchestrate All the Things. I'm George Anatiotis, and we'll be connecting the dots together. Stories about technology, data, AI, and media, and how they flow into each other, shaping our lives.
It's early 2025, and we may already be witnessing a redefining moment for AI as we've come to know it in the last couple of years. Is the canon of more GPUs is all you need about to change? Truth is, when we arranged a conversation on AI chips with Chris Cachris, neither the Stargate Project nor DeepSeek R1 had burst onto the AI scene. Even though we did not consciously anticipate these developments, we knew AI chips is a topic that deserves attention, and Cachris is an insider.
I hope you will enjoy this. If you like my work on Orchestrate All the Things, you can subscribe to my podcast, available on all major platforms, my self-published newsletter, also syndicated on Substack, HackerNoon, Medium, and DZone, or follow Orchestrate All the Things on your social media of choice.
My great pleasure today to come back to a returning topic, the topic of AI chips. It's something that we first started exploring 7 years already back. So it first started in 2018. And I have to say in advance that originally I had no background on the topic whatsoever, other than the general background that computer science graduates get. However, at some point, I felt that it was important to educate myself on that, well, for sort of obvious reasons, because AI is and had already been a topic of growing importance, and obviously what's fueling growth and what's also setting the boundaries on what's possible with AI is hardware. And more and more, we have been witnessing the evolution of hardware as well, with more and more specialized and more powerful so-called AI chips. So in order to explore the latest developments in this area, we have the pleasure of hosting today with us Mr. Chris Cachris. Chris is a man who wears many hats. He has been in the industry, driving the development of a startup called InAccel. He'll share a few words on that. And he has also been, and still is, in fact, a researcher, working on a number of topics under the AI chips umbrella. So, Chris, thank you very much for making the time for today's conversation. I'll pass on to you to do a slightly more nuanced intro of yourself than the one I did for you.
Thank you, George. Thank you very much for the invitation. I'm happy to be here. So I finished my PhD in computer engineering in Delft University of Technology. And then after spending some time in the Silicon Valley, in Xilinx, then I came back in Greece, working on several research centers. And at some point, I was in the Technical University of Athens and doing some research on specifically on the FPGAs and how they can be utilized in the domain data center and in the cloud. And out of this research, we try to commercialize our experience. So this is how we started InAccel with Ilias Koromilas and Ioannis Tamelos. And the main goal of InAccel was how to utilize FPGAs in the data center and in the cloud. So we spent 5 years at InAccel, and then I went back to the university, right? And so now I'm in the University of West Attica on the Department of Electrical and Electronic Engineering, and still working on several research areas in the domain of AI, cloud computing, and especially edge AI. So it is an exciting area. It is really an exciting area. You see a lot of innovation, and you see a lot of innovation coming both from the industry and from academia, right? So you see a lot of research efforts from several universities, especially for the large language model. You see a lot of innovation of AI chips, mostly from industry, because it is an extensive, expensive sport, but also from academia, right? So it is a very exciting area.
Great. Well, thanks for introducing yourself and also giving a little bit of background on the area. And since the whole idea is trying to contextualize the discussion in current developments as much as possible, and what's on everyone's minds these days is, well, a number of things which I find are somehow interrelated and also provide a good background to this conversation. So on the one hand, that's a few days ago, we have the announcement of the so-called Stargate initiative, which is kind of, you would maybe call it like a public-private partnership, because it's an initiative that's announced by OpenAI, so the makers of ChatGPT and so forth. But at the same time, they have the endorsement and backing of the US administration, plus a number of industry heavyweights. So the idea behind this initiative is to build infrastructure specifically for the US to enable them to compete and to outcompete rather the rest of the world, basically. And that's a continuation of what we have been seeing in terms of US policy in the last couple of years. So their policies have basically been trying to give themselves an advantage compared to the rest of the world by doing things such as imposing limitations initially specifically for China and the BRICS countries, but as of late, they are also trying to impose limitations to access to GPUs for the rest of the world as well. And at the same time, some days ago as well, we are seeing another interesting development. So the rise of open source models, largely capable large language models, open source language models made in China, that are rapidly climbing the leaderboards of these models and are displaying very interesting capabilities at a fraction of the cost of what it normally takes to train these types of models for the rest of the world, let's say, and despite having all of these limitations. So that already sort of sets the scene, let's say, for the beginning of the conversation. And I thought that we can have a look at the implications, let's say, of the development of AI chips on different levels. So we are sort of de facto starting with the upper layer, so the geopolitics scene. So what the Chinese companies have managed to achieve is basically developing top quality, top capability open source large language models, while at the same time facing restrictions in the compute power available to them. So I think it's worth exploring how exactly they have managed to do that. Based on the information that we have available to us, it seems that, well, China is not entirely deprived of the latest of GPU power. However, they have very limited access to the latest models. At the same time, they seem to be strengthening their internal industry. Chinese companies are developing GPUs of their own, and they're also doing something very interesting, developing techniques that enable them to mix and match different GPU types and models. I'm sure that you must be able to shed some light on this.
Yeah, very interesting because it is an expensive sport, right? If you are working, especially if you want to develop a processor, an AI processor, especially for the training, but also for inference, it is very expensive, right? So you need to allocate a lot of resources, not only in terms of money, but also in terms of talents, engineering, etc., right? So the Stargate initiative, it's very it's complementary to this CHIPS Act that in US that it's trying to make a much more stronger the US technology and not so much depending on third parties like they have to outsource the manufacturing at TSMC or other companies, right? And we saw that during coronavirus that it was some limitation, and especially in the supply chain, exactly because the whole planet was basically depending on one or two companies based in Taiwan or some other places, right? So I think it's towards the right direction because they're trying to diversify the fabrication and they want to bring back the know-how, right? Because the manufacturing process was initially developed in the US, right? And then they outsource it some companies, and now I think it makes sense that what they are trying to do is bring it back the expertise that they have, right? So it is definitely towards the right direction. And at the same time, they have to compete China, in which we know that the government strongly support these initiatives, whether it is, the chips, whether it is the large language models, etc. So China, the government of China is very strongly support all of these companies working toward these directions. And of course, it makes sense also in US and of course in Europe, right? To try the governments there to try to support these initiatives. Now, it's very interesting because of what you mentioned about the China large language model. The interesting part is that they not only open source the model, but they also open source the training data. That is really something because most of the open source models usually they don't or they hide the training data for several reasons, right? It can be that they infringe some copyrights. It can be anything else. So a lot of companies or a lot of industries or organizations, they are kind of reluctant to open source also the training data because I don't know, it may be some infringement of the copyrights, patent, something, anything, right? So it's really something that they open source also the training data, right? So and not forget about Europe that. I think these initiatives must also be applied also to Europe, right? So definitely Europe does not want to stay behind on this one. Um, it's hard to compete with NVIDIA, right? NVIDIA right now has 80-90% of the share market, especially in the data centers, in the cloud, right? So, and it has huge amounts of money that they are willing, to keep innovating. So it's very hard to compete. But I think what it's really interesting is that still there are two things, right? It is first of all, it is the chips that they are used for the training data, and then they are used for the prediction or for the generative AI, right? That you want to do the predictions or you want to do the to generate some text, the inference chips, right? So for the training of the data, so NVIDIA is the leader, and then you have some companies like AMD, you have the Intel with the Gaudi chips that they try to compete, and they have some very good results, right? So it's very hard to compete there. But in the domain of inference, when you want not so much of floating point operation, etc., this is where there are space for several companies, startups, both in US, in Europe, in China, to innovate. And this comes from the fact that if you are talking about, for example, embedded systems, right, you need different kind of chips for the text, for the video, for different sectors. You need different kind of chips in the factories. You need different kind of chips in the hospitals, in automotive cars, right, in autonomous cars, etc. Right. So I think there is a space for innovation, specifically in the domain of edge AI.
Okay, so interestingly, you did mention Europe in this kind of landscape, let's say, of sorts of how different parts of the world are trying to cope and to compete in this AI race, let's call it. And one of the notable things about Europe is that I've seen like many voices, let's say, that are calling for more investment in AI, in compute for AI, and specifically in GPUs. And we would have to assume precisely because of what you said. Well, when people talk about GPUs, they generally mean NVIDIA GPUs. So this is one way to go, and it also seems to be the way that the US Stargate initiative is pointing to. So basically, more compute and more power. However, I'm wondering, is there maybe something that the rest of the world can actually learn from the way that the Chinese open source models are being developed? Because it seems to me that maybe they have managed to be more efficient in the way that they do things, and also to having to cope with the restrictions that they are facing, maybe more creative. So not just rely on just throwing more compute at the problem, but trying to make the training process more efficient, and also to combine different chips, not necessarily the latest models, the more powerful ones, but doing so in a way that that is more creative, let's say. Do you think that is the case? And if yes, is that something that the rest of the world can learn from?
Definitely, it is a good use case because there is this motto that first you copy, right, but then you start innovating, right. So this is a typical, for especially a good way to start is first to copy the leaders, right, and then to start innovating. And we have seen this, what is happening, for example, with the electric cars, right? So for example, a few years ago, there were a few major Chinese companies developing electric cars, and now you see that there are some kind of leaders, right, outperforming even Tesla. So the same, I think, it's going to happen also for some domains, right? First of all, about the large language model, it's very interesting to see that the fact that they open source also the training data, and the fact that they have managed to to outperform some other models, even with less parameters, means that there is a room for a lot of innovation, right? There, and they have given a very, very good example. Now, the other thing that you mentioned, they can, for example, mix and match, they can combine different versions of GPUs and other processing units in order to create a powerful data center or cloud. This is very useful, especially if you think that now every 1 year, right? In the past, you have to buy some new equipment every 3 years, every 4 years, etc. Now the innovation is so fast that almost every year you have more and more powerful chips and more powerful processor, and it does make sense to throw away processors that are 1 year old, 2 year old, right? So definitely you need to find a way to utilize the resources, even if it is a kind of heterogeneous resources, right? Even if there are different resources, not even GPUs, right? You can allocate resource, for example, you can utilize resource from GPUs, FPGAs, typical x86 processor, etc. And this would be much more cost efficient, right? Instead of every time buying the latest processors and throwing away the older one. So definitely makes sense, and we have to learn something from out of it.
Right, so that's a very good cue for the next question I wanted to throw at you, which is sort of giving us a brief tour, let's say, of the other options out there. So if for whatever reason you don't have access to the latest and greatest NVIDIA GPUs, what else is out there? I know, for example, you are very proficient in FPGAs because this is what you have been working for a number of years. However, there is also other options. So one that I've personally been trying to keep an eye on for a number of years is the RISC-V architecture, and I find that very interesting because it's an application of the open source idea in the domain of hardware. So I find that particularly interesting. There's also the idea of chiplets, so combining, let's say, different units on the same chip, and there's also custom chips and ASICs. Which one of those do you see as viable for as a viable GPU alternative?
Okay, so if we go to the training part, right? There are some very good initiatives like the one from, for example, Google has its own TPUs now. It is version 4, right? And they're coming version 5 that they are really powerful, right? And AMD at the same time is releasing a MI300 CPU that's also very powerful. And it's interesting to see that inside there are specialized units accelerating transformer algorithm, that it is the basic block of the ChatGPT and other algorithms, right? Intel has Gaudi chips that they're also very powerful, right? So you see that there are some alternatives. The nice thing about, for example, NVIDIA is that they don't sell just the chip, right? So a very novel idea is that they decided to go to sell the whole system, right? So instead of selling just the chip and trying to support some other vendors, board vendors or CPU or computer vendors, rack vendors, etc., they decided to go vertically, and they decided to provide the whole system, this DJX systems, so that it is AI in a box somehow, right? So that gives them the room to make some innovation. For example, they use their proprietary NVLink interfaces, right? Whether the other companies, they're still based, the communication is still based on Ethernet, that it's not so fast as the NVLink, right? So one innovation is that NVIDIA decided to provide the whole system, not only the chip, right? So while other companies, for example, Intel, AMD, they're just selling the chips, and then they are based on some other vendors that they have to do the integration. So this creates some problems because usually, especially cloud providers, etc., they want to have the whole system, etc., or even universities or research centers or companies, they just want to have the box that works seamlessly. The other thing is that they have also a great ecosystem, right? So they have the software platform, they have all of these things. On the other hand, now if we go to the inference part, right? I think there is as I said before, there is a big room for innovation. You don't need so much powerful devices, right? So of course, NVIDIA has the A10, A30, the most cost-efficient T4, for example. And AWS has its own chip called Inferentia. And especially in this domain, FPGA, for example, can prevail because they can provide much lower latency. That it is very critical in some applications, right? When we're talking about inference, we're talking whether you send an image and you want to see the prediction, or whether you send a question and you want to see the answer, right? So FPGAs are very good because they can provide low latency. And of course, you can see also other companies. You can see Krog, Cerebras, Graphcore, Sambanova. There are several companies that they are trying, to gain some market share, especially in this area. And what you mentioned about this, the chiplets that you have, even if you are a startup, you can develop your own transformer accelerator, and you don't need anymore to develop your own chip. You can just provide the IP core that can be fabricated into a chiplet, and then the chiplet can be integrated with processors, with memory, etc. It is still very challenging because if you want to develop a chiplet, you need also very fast interconnection network, right? So that it takes a lot of area, especially in the die, right? So there are still some challenges there, but definitely in the domain of edge, it makes sense, to try to allocate some resources and try to do some differentiation there. And I think also if we talk about, for example, let's say in Europe, right? So currently, right now, Qualcomm, Snapdragon, these devices that are everybody's phone, they have specialized units for AI, right? So, but in Europe, we have also very good companies like STMicro and XP. Traditionally, we have good companies that they are good, especially, and they have a good market share, especially in the domain of edge and edge AI. So I think there is room for innovation, either for for Europe, for European companies, and the European ecosystem, especially in the inference part where you see a lot of possibilities, right? This is something that is supported by several people, right? From Cambrian AI, Christos Makiyamos, and several researchers support that there is a room for innovation in the domain of inference, especially in the domain of edge AI.
Okay, yeah, actually, yes, your view, I think, is corroborated by a lot of independent analysts and researchers that, and also it makes sense from a go-to-market point of view, because even if training is very expensive computationally, actually the bulk of the compute operations in the lifetime of any AI model will be in inference. Yes, it does cost a lot to train it, but the actual operation will in due time actually accumulate to a larger amount of compute. So it also makes sense to focus on inference from a business perspective. Another important aspect, and actually a part of the reason why NVIDIA is in the position that they are, is the fact that they have invested heavily in their software stack. So the CUDA platform is pretty much omnipresent, let's say, and people are getting familiar with it from very early on. So it's very extensive, and there's a very good developer advocacy program that makes sure that everyone knows how to program there. Obviously, this is something that competitors realize, and therefore, in the last few years, we are seeing efforts to sort of replicate, let's say, not necessarily in terms of feature, but learn from what CUDA has achieved and try to build an alternative ecosystem. So we are seeing the One API initiative, which is spearheaded by Intel, and also AMD is trying to build its own environment called ROCAN. What's your opinion on these efforts? Do you see them gaining traction and being positioned that they may be in the future in a position to be competitive to what CUDA is able to offer to developers?
Yes, this is a good point, because at some point CUDA started, not only for graphical processing units, but for GPUs and for games and etc., but also for high performance computing. And then at some point, there were a lot of researchers trying to program GPUs in CUDA, and of course, NVIDIA was very fortunate because a lot of matrix multiplications that especially used in the GPUs for video games. It's also the struggling point, or the most computational intensive part, also for AI, for HPC, for generative AI, etc. So, and they built on top of that, right? So they were very good at matrix multiplication. So they were able to transform this innovation also for generative AI and for AI application in general, right? So so the software part is very important, right? Because at some point, whether you are a developer, you want to, even if another chip is better at AI or at HPC, you don't want to rewrite your code at all, right? Whether it is written on C, C++, CUDA, etc., you need to be able to support any kind of a chip regardless of the programming language. And I think this is why one of the reasons that FPGAs were struggling, because it was very hard to program, even using high-level synthesis. It was very hard to program, and once it was they released OpenCL and HLS high-level synthesis, then it became much easier to program FPGAs. But if we go now in the domain of AI and generative AI, I think the companies, especially the vendors, the chip vendors, need to provide an easy way to program these devices, right? Even if they have better performance, if it's not easy to program them, then they will not buy it, right? Because no one wants to rewrite the code. So it is very important that you, if you are able to program these devices, whether it is in CUDA, in Roca, One API, but especially if it is easy to go from Python, from Keras, from frameworks like this one, from TensorFlow, etc., to be able to program this one. And that's why we see that there is, for example, Hugging Face, right? So it's very important, because using this framework, it's much easier to explore and compare different platforms, because you have everything there. You have the data set, you have your code there, and it's very easy to compare different solutions there, right? So the software part, it's very important, right? So the software stack, right? You need to be able to program these chips very easily without having to rewrite your code, right? Whether it is in CUDA, it is HLS, or C, C++, Python, it is something very important, but a lot of vendor companies, usually they don't pay so much attention, and at some point they find it in front of them, right? So because they provide the best results, but then nobody is going to bother, because you need to rewrite your code, or you need to to learn a new language, right? So it's very important to provide the software stack that it's easy for the end user.
Right. Just out of curiosity, when in your work with FPGAs, how did you manage to get around this issue?
Yeah. So actually, this is our competitive advantage, right? So at the beginning, we start providing accelerators for machine learning in the FPGAs, but then we saw that this was the struggling point. I mean, nobody was willing to change how he writes code, right? So what the main innovation of InAccel was that we developed the middleware that allowed the data scientists and ML engineering to be able to utilize the FPGAs without having to change a single line of code, right? So this was the most important thing, and that it was recognized by several vendors, that we managed to expose the FPGA resources to the end user, to the data scientist, to the machine learning engineering, and to be able to utilize the performance of the FPGAs without having to change, for example, their Python code, right? And just by importing a simple library, they were able to utilize the FPGAs. So, and this is how we made some traction, and this is how we a lot of companies that are starting using our framework, etc. Right? Because we knew right, that the data scientists and ML engineering, they don't want to rewrite their code. Right? They don't want to change even a single line of code, and this is very important for the important lessons for anybody working on the domain of semiconductors and processors. Right? You need to provide something that is able to be to program very easy.
Mm-hmm. Right. So that makes me wonder specifically about Intel, and I think it's very relevant to this conversation because of two things. First, it seems that Intel, in a way, exemplifies what you just mentioned about the software being just as important, or maybe even more important than the hardware itself. So, as you mentioned previously, Intel has its own line of AI chips that they got through an acquisition, which is called Gaudi. And the latest Gaudi version, Gaudi 3, seems to have missed its sales target, largely reportedly due to software, basically, because of the fact that software to access it, to program it, was not in good shape, and therefore that caused them to miss their targets. And another interesting piece of intel about Intel is the fact that they seem to be out in the market trying to sell off their FPGA branch, which is called Altera, and that makes me wonder. Even though through the acquisition of InAccel, they seem to have managed to now offer a software layer for FPGAs that, as you mentioned, enables people to use them. They still, judging from the fact that they're not seem to be interested in retaining their FPGA unit, they still don't seem to be able to to make the most of it. How do you explain that?
Okay, so FPGAs can prevail in several sectors, especially because it has this low latency and much higher energy efficiency. There is not any killer application for this, but both Xilinx and Altera, when they were standalone, they had a lot of revenues because they were able to sell these FPGAs in several sectors, from telecommunication sectors. That was the main, okay, mostly the killer application was the telecommunication application, networking, military application, etc. Right, so they have some advantage that it's not always easy to utilize in sectors like, for example, the training part, right, the data center. However, still there are some very good use cases, right? So for example, Microsoft Azure, they are utilizing FPGAs in order to process, for example, some the searching, and because they have coupled very novel, in a very novel way, the FPGAs with the Xeon processors, right? There are some very good examples of how they have how the FPGAs can prevail and can provide several advantages, right? And it is not the killer application, for example, the AI training, and this is how, for example, NVIDIA is currently the dominant player there, right? However, there are still very good use cases, right? I told you about the telecommunication, networking, etc., where FPGAs traditionally are being used and can offer several advantages: lower latency, lower energy efficiency, and several other advantages, lower cost.
Okay, so I guess then we'll have to come to the conclusion that it has mostly to do with Intel's business strategy than the actual capability of the hardware itself.
Yes, I guess so, right? It is. I guess it is in the same way that they tried to spin off the foundry. They have now. They try to have a separate company for the foundry that can serve also third parties, right? So I think that this is part of the Intel strategy to have it separate.
Right. Okay. So another interesting area to explore, which you also touched upon already, inevitably, I may add, is this separation, let's say, between training and inference. And for most organizations, actually, training, I don't think is something that they will get into that much because it's complicated, it costs lots of resources, and also simply because of the fact that on a daily basis we are seeing new, very capable models being released, either as open source or in proprietary models, and there are many ways, we are already seeing many ways that people and organizations are exploring the use of these models, either by leveraging APIs, typically the APIs of OpenAI or Anthropic, that are building these proprietary models and making them available under certain licenses and terms and so on. So it's a very common way for organizations to start experimenting, or potentially many of them actually stay on that trajectory, let's say. Others, however, choose to first start that way because it's simpler and faster, and then when they mature their use cases, what many of them do is they take some open source models and then try to adapt them to their use case. So that brings us in the area of inference. And by the way, something interesting that I sort of stumbled upon lately is the fact that there are already applications and frameworks that enable people to run these large language models even locally on your local machine, assuming that it's sufficiently, let's say, powerful. So for most people, it's actually the inference that matters. And I know that you are also involved in a research effort recently that was precisely about exploring different ways to enable faster inference, specifically for large language models. So I was wondering if you could summarize your findings, and most importantly, whether any of these methods and frameworks that you investigated you think has the potential to be directly transferable to how people utilize these and run these models.
So it's very interesting area, right? Especially for the inference part. And as you mentioned, most of the companies, even if they want to have a specialized LLM, what they do is transfer learning, meaning that they use an open source large language model and they try to fine tune it or adapt it, fine tune it using their own documents, right? In order to make it more relevant to their area, right? So, and then they mostly care about the inference part. Now, the inference part is very tricky because you don't need to go into 64-bit or 32 bits. You can even do the processing using 16-bit or 8-bit or even 4 bits, right? So you need specialized architectures. And there are even some startup companies that they are doing, for example, chips that it is specialized only for the transformer algorithm, that it is the most computational intensive part. Now, in the domain of, what it is from commercial available right now, it seems that FPGAs and GPU can provide the best performance, and when it comes to energy efficiency, maybe FPGAs can provide better energy efficiency compared to GPUs. But if we look at a little bit long term, right, in 3 years or 2 years from now, there are some potentially, especially when we're talking about in-memory computing and the memory storage in general, meaning that there are this technology that you can couple together the now you have the memory and you have the computing part, right? With in-memory computing and memory store, etc., you can combine together the memory and the computing power in the same way like our brain works, right? So if this technology in memory computing can be commercially available in a cost-efficient way, then it can provide much better performance compared to the typical processing technology, right? That is currently using the typical CMOS technology. So I think that in a couple of years, we are going to see some novel technology using in-memory computing, memories, etc., neuromorphic computing, as they call it, right? That it is based on neuromorphic computing that can provide much better performance. currently we see that the performance that the current chips have, it's really impressive, but in terms of energy efficiency, it's much lower compared to how our brain works, right? Neuromorphic computing and in memory computing, it's much more closer to how our brain works, and it is much more energy efficient. So I think there is a room for innovation and some room for research, especially in this domain, as long as there are some cost-efficient solutions that can be commercially available. It's not very exotic.
Mm-hmm. Yeah, actually, that's a very important parameter, and one that I'm personally glad to see that many vendors are starting to pay more attention to and emphasize. So it's not just about performance itself, but it's also about the performance to energy consumption ratio. So yes, and in that respect, having an energy efficient solution is very important for a number of reasons, ranging from financial to environmental. So is this a direction that you see your research moving towards?
Yeah, so especially in neuromorphic computing, you need a mix of experts, right? A group of experts, because it has to do with also with analog electronics, digital electronics, etc. Right? So you need a larger group, right, in order to do some research in this domain that can have some expertise both in the analog, mixed signal, digital domain, etc. But definitely, I think that some new technologies, right, whether it is neuromorphic computing or some other thing, uh, definitely it's going to provide some much more energy efficient solution, because the energy is translated to the energy bill, right? Because at bottom line, what most of the users are interested, how much tokens you have per dollar, right? And the dollar is depending especially on how much this processor consuming, right? So definitely, I think it makes sense to try to explore some other solution in order to find some much more energy efficient or cost efficient solutions.
Right. So speaking of users, and again, sort of coming back to how most users end up using the available AI models and technology, again, for most of them, it's either through someone like OpenAI or Anthropic, or, which is probably the most typical scenario, through one of the hyperscalers. And I think it would be amiss of us not to at least mention what the hyperscalers are doing in this area. So, um, my summary would be that it's a kind of competition game. So all of them are very much collaborating with NVIDIA, because obviously it's the dominant player. So they have to stack up their data centers, and they have to provide the latest and greatest options to their users. But at the same time, because they don't want to be dependent on a third party, they're also investing heavily in developing their own custom technologies and AI chips. So I was wondering if you would like to offer like a brief take on each of the hyperscaler strategy, and which ones you see potentially standing out, and in what ways.
Yeah. Um, it's a nice question, because there are, if you are a chip vendor, there are several ways that you can try to sell and promote your product. And we have seen some of the chip vendors, Kroger, Graph, etc. We see that some of the vendors, of the chip vendors, they even try to have their own resources or their own cloud and provide their FPGA or their product as a service, right?
Mhm.
So we see that in some cases this is also a good market fit or a solution to go. That instead of just trying to sell the chips, you just you keep the chips for yourself, and you build your own infrastructure, right? And you provide the infrastructure as a service, or you provide the application as a service, right? So this is also an interesting strategy, right? What you mentioned now about the hyperscaler data center, this is very interesting because, for example, we saw that AWS, they have their own chips, right? They have the inferencia, and Google has its own chips, TPU, but at the same time, they need to have also NVIDIA GPUs to offer to their clients, right? So it's a balance that they have to do some balancing between their own chips and the NVIDIA to offer third-party solution, right, at the same time. So you cannot exclude it, right? So you cannot only offer TPUs and not NVIDIA, since most of the users they're using NVIDIA chips, right? But at the same time, you need to have a competitive advantage. So it's very interesting story, and it is very elegant, to try to balance these two forces, right? But I don't know. We will see what happens in this domain.
Yeah. I think one interesting development, let's say, along those lines is the fact that, to some extent at least, it seems to me like NVIDIA is also trying to do a little bit of the same with their NIM offering. So they're offering inference as a service, basically, which is, I guess, their way of addressing the very large inference market in a way that is also useful to their users.
Yes, I guess that the hyperscaler providers will not be very happy about this initiative, right? Because it is competitive to their core market, right? And NVIDIA, on the other hand, does not want to lose their clients, right? Because Amazon, AWS, etc., it's the largest customers, right? So it is really, I'm also very curious to see what will happen, and if NVIDIA will manage to attract a lot of users and attract users from other spaces, right, or from AWS or from Azure or from Google Cloud, right? So it's it's a very elegant trying to balance these two markets. You need to handle it very carefully, I think, right? Because you don't want to lose also your main customers.
Indeed. Yeah. Okay. So I think we're close to wrapping up. We have just a few minutes left. So let's do that by asking you to highlight some of the directions that you think are most promising for future developments. You already pointed towards neuromorphic computing, and we sort of covered chiplets a little bit as well. There are also more exotic, let's say, solutions such as photonic. We have seen with interest some new developments in photonic that seem sort of promising. And again, coming back to the software stack, we are also seeing the emergence of new programming languages that are specifically tailored for AI models. And the promise that they bring is being closer to the hardware, such as Mojo, for example, which is sort of like a reimagining, let's say, of Python, but with being tailored specifically for AI chips and being more performant. Which one of those do you see as more promising going forward?
It's hard to tell, but I think we are going to move like we are going to see a lot of new vendors, especially in the domain of embedded system and edge AI, where we will see, I think, specialized companies, specialized for wearable devices, or specialized for military, for specialized for video or for text. And I think there is a huge market, right? Especially if we talk about the edge AI. And even if NVIDIA has a big percentage, even at this domain, there is room for some innovation, there is room for some companies. I think it's going to happen, the same thing that happened, for example, let's talk about the GPUs, for example, right? So NVIDIA is the leader in GPUs, but there was lack of GPUs for a wearable device, for example, for smartwatches and for a Fitband, etc. And we saw that, for example, a Greek company, the Think Silicon, they developed a GPU that it was specialized for a Fitband or for smartwatches, etc. And it was acquired by Applied Material, right? So I think the main innovation is going to happen in areas that they are too small for companies like NVIDIA or Intel or some other companies, but it is good enough for smaller companies that they can make specialized product for this area, right? So, and there we can see some exotic solution. It can be neuromorphic. It could be, for example, photonic. We will see, right? In-memory computing, etc. But exactly because there are different requirements and different specification in the domain of edge AI, I think there is room for innovation in this area, right? Especially in the edge AI, for video, for text, for different requirements are for example, for the hospitals, for the autonomous driving, for the aviation, anything, right? Consumer electronics, etc. So I think I would definitely do some research, especially in the edge AI.
Great. Well, thank you very much for the conversation. And it's actually my goal always when having conversations like this is to learn something from the people I'm having the conversation with, and that definitely was the case today. So, thank you very much for your time, and good luck with whatever it is that you choose to focus your next research on.
Thank you, George. Thank you for the invitation.
Thanks for sticking around. For more stories like this, check the link in bio and follow Link Data Orchestration.